Dialysis tubing is a plastic material that's semi-permeable, and so it acts as a plasma membrane of sorts, and it allows certain materials through and others cannot get through. So we tested what things can get through and what things cannot. So we created these cells out of this tubing, and we tied off one end and knotted the other. And we had 5 different solutions. Our first was an isotonic solution, so we put water in the cell and water in the beaker. And our second, third, and fourth were different measures of glucose in the cells. So our cell B was 20%, cell C was 50%, and cell D was 80%, and they were all put in water, so they were hypotonic. And then our last one was the opposite, and so we had glucose, 80% glucose in the beaker and water in the cell. So we searched for diffusion patterns, and we observed how the mass dropped over time.
So some molecules do diffuse through the cell membrane. So these include water and lipids, but glucose and salt, we didn't test salt. But from what we've heard, it does not go through, and glucose also does not. And the reasons are essentially that glucose is polar, and it's too large to pass through the phospholipid bilayer. However, water can, because it's small and it goes through the cell membrane through osmosis. And the ways that we discovered this was because in cell E, we had only water in the solution, 80% glucose in the beaker. So the cell lost mass because the water had to diffuse out of the cell into the beaker solution to attempt and create an equilibrium between the concentration of the cell and the solution outside of it.
So these are tables, and we tested over time. So our data was pretty wrong. So the second table is what it should look like. But in the first cell, cell A, the mass is supposed to stay the same because it's water inside the cell and inside the beaker. So what is dynamic? Isotonic. And then the other ones, depending on how much water concentration was inside the cell or outside the cell, the mass went up or down. So this is the actual change over time, not just the numbers. So you should probably look at the theoretical data because that's right. And so the graphs, the reason that this purple line goes down is because it lost mass, right? But then all the other lines go up because they gain mass. And this green line is opposite of the purple line because the beaker and the cell concentrations switch at the beginning.
And then we compared the average rates of diffusion versus the concentration of syrup. So the concentration of syrup in the cell. This is also based on our data, so as you can see, cell A shouldn't have had a diffusion rate at all. And so you can see that the diffusion rate increases after 0 because as the concentration of glucose increased, so did the average rate of diffusion because the pull on the water molecules to the solute is higher, so often delivering more. And you can see that through this graph because there's a really large dip as the concentration of syrup increased to 80%.
All right. I don't understand your last graph at all. Go back, please.
It was based on our data, so it wasn't accurate.
Is that a line of best fit that I'm looking at? Is that like a binomial line of best fit? Or like, what did you do there?
No, I think it graphed the points that we had and then kind of made them rounded, I guess. So if you look at the other graphs.
Yeah, just like.
Wait, all of your average rates were negative? Okay, yeah, I'm gonna throw up. They're all negative?
Yeah, so that was our data. I think we did something wrong.
Yeah.
Yeah, our data was very
Because a lot of the cells leaked.
But go back to the one graph before that, because the graph before that doesn't show that you have all negatives. Oh, yes, it does. Oh. That's, okay. Cassidy had a question.
Do you know you did incorrectly to get the information?
So essentially what we did wrong that messed up our data. So just our cells leaked a lot. We couldn't do anything about that. We did all we could.
Is there anything you would do to prevent it if you were to do the log over again?
Just like tie it.
Yeah, tie it a bit tighter. We tried cell E kept leaking. We kept trying to do it and it didn't.
Yeah, it didn't
Do
work like
anything.
But we were able to get like the general idea of it because we realized that as the like concentration of glucose increased, the like osmosis occurred.
Okay, I had one other question. So can you go back before you talked about, so just to be clear, this was not a membrane. Like it was a piece of plastic with certain size holes in it. So that wouldn't determine what goes through except for based on size, right? So it's not about polarity here in your, because yours is not an actual cell, right? Does that make sense to you? Okay, I just want everybody to understand that they weren't testing a cell; they were testing a semi-permeable membrane with specific size holes in it. Ella?
Is this the same stuff that they use when they go through blood and such?
Dialysis tubing. There are medical uses for various sizes and materials like that. Yes. Yeah. Yeah. Okay. Any other questions for them? All right. Thanks, guys.